Thanks, everyone, for joining. Today, my name is Pedro Oliveira. I'm a solutions architect at Spectre Cloud, and I'm joined here by my good friend Itzik from Unveil. And we'll be talking to you guys about an awesome, if you ask me, use case about Kubernetes at the edge for smart agriculture. So, Itzik, take it away.
Hello, everybody. Do you hear me? My name is Itzik. Yeah, the same person, Pedro. I'm from Unveil, Israeli startup. And what we are doing in Unveil, we pick fruits with flying autonomous robots. Have a look. This is our flying autonomous robots, connected via power supply and networking cable to a central units that processing the sensors and with sophisticated AI, searching, navigating, detecting the fruits, and in the end, as you see, very gently picking the fruits, all autonomously, all done by Kubernetes. Cool, right? But seriously, why to use robot? First of all, to make very long story short, there are no pickers. There are no enough human pickers in the world, and it's seasonally work. So you have something like 3 or 4 months at the most in a year to pick your fruits, and it's difficult to hire these pickers, so 20% of the fruits are staying to rot. And we are in Unveil believes that less people should feed more people. But on top of the crops, the robots acting as a data agent for color grading, weight, if the fruit is ready to pick or not, and even it's detecting disease. Before I show you why we choose to use Kubernetes, I want to show you the technologies issues or challenges that we face with. First of all, our robot can do much more things while it's not picking. As you remember, you have something like 3 or 4 months in a year to pick, and the rest of the time it can do pruning and spray and much more other things. As far as we want that our robots will be autonomous, we want that our application will be autonomous. So it means that when he has failure and he needs to be recovery, you need something like Kubernetes to do this job. Because, come on, guys, fruits are not waiting for software update. So it has to be fast. I want to show you where we are working. Here our deployment. Here where we put our Kubernetes clusters, far away from the buildings, far away from your antennas that use 5G. If I will have here 1 or 2 megabytes of downloads, I will be the happiest man in the world. It's very difficult to deploy. And right now, in these days, right while I'm talking, we are picking in Chile. So imagine that our headquarters sit in Tel Aviv need to support these guys at the field and risk from theft. A lot of challenges when you work in a rural network, a rural environment. Imagine that.
Not like AWS or GCP,
Yeah.
right?
No, you're not managing the cluster at the cloud, on the field, no network. So anyway, I want to show you how we started. You know, as a startup, you need to run and run fast. So each developer at the beginning had his own robot, and he needed to SSH to his robot, manually script, to remote the robot, different setup, the engineer host and the deployment host. Works in my machine syndrome started. You know how it is. The installation, manual installation was painful. High onboarding on when you want to operate, And when you want a new development, was impossible to operate multiple drones. It was too many screens. What we did, we used containers. Look at that. We use Docker to easy setup and easy replication. We use Docker to freeze our setup. And we build a small web UI to control everything. But we still had some problems. When you're handling containers by your, manually, it's difficult. Our images was huge. I'm talking about 4 years ago. The images were huge, heavy, and the build was difficult. Deployment was separately between the operation station and the robot. Multiple robots was still hard to operate. Hey guys, what about try Kubernetes, huh? We divided our application to microservices. The images was slim and thin. You can move apart very easy. We combined the deployment to one deployment for robot and operation station. We added service to monitor and control via web UI. Multi-robot now is a breeze. Problem is solved. Kubernetes help us a lot. But when it's come to scale, it's difficult. It still has challenges when you try to scale edge. You need to gather all statuses by your hand. You need to be sure that you need to make sure that your cluster up and running all the time. And you remember, far away from the antennas, and it's difficult. You want to care about security, and you don't want to do that manually of a lot of edge device. And we are in Unveil wanted to focus on application. We want to focus on picking fruits, not on operation system, upgrades, NVIDIA. Imagine that. Because more apples, more scale.
Indeed. So yeah, more apples, more scale. And as we were working with Unveil, we basically identified 4 needs that we had to solve in order to actually run hundreds of these multi-purpose robots dispersed geographically. As you heard, we have robots in Chile right now, also in Italy, and in the US. So the 4 pillars that we identified are essentially easy provisioning of operations, functionality when it's disconnected, full stack security, very important, and zero risk upgrades as well. And those are the ones that we're going to be talking to you guys about and take you through that journey. But before we do that, let's take a step back, because you might be wondering, what does the Unveil architecture look like, or what are they deploying down into the field? And although it does look overly simplified, it's very complex. Itzik, you'll probably say that very well. But essentially, there's a ground control station that is a Kubernetes cluster, which is operated by an operator. And that's wirelessly connected to these bins. And these bins can manage for up to 8 multi-purpose robots for the fruit picking or pruning, whatever else Unveil wants that to do, right? So one ground control station can manage n number of bins. So that's basically the architecture. But now let's look at managing Kubernetes clusters at scale at the edge. So for that, we have Spectral Cloud Palette, which is a Kubernetes orchestration tool designed for managing Kubernetes at scale, which allows you to do that on any data center, public clouds, and obviously at the edge. And what Palette does is it has essentially for edge, very important, a very distributed architecture in the sense that every cluster runs its own Palette agent as well. So we basically separate the management plane from the control plane, which it will make a lot of sense when you have disconnected use cases and when there's no bandwidth. So with Palette, you basically specify the desired state of your cluster, which we call a cluster profile. And that desired state goes from the OS, like Itzik was saying, they don't want to be playing around with OS dependencies, having to install NVIDIA dependencies and kernel dependencies and all of that, all the way to the application. And that includes also all the integrations in between. And with that, we call a cluster profile. So with Palette, you basically specify a cluster profile. You then push that cluster profile to a cluster, and the cluster then manages itself, right? So it reconciles and is able to manage itself with all the configuration and policies as well. So I wanted to just give you guys an understanding of that before we move on. So easy provisioning, but what does that really mean when we're talking about edge, right? So specifically for Tevel's use case, and most probably like 90% of the edge use cases out there, connectivity is always going to be an issue. Security is always going to be an issue. So how do you provision edge devices? And Itzik told me a while ago, he was like, I want to be able to go to Best Buy, buy a box, boot it up, and get it to work, right? Because there will be instances where there will be the pickers and the bins will go out, and they will have to quickly recover them, and maybe they don't have it staged there, and they have to go and quickly do that. So provisioning, which could be in the field or at the distribution center, is very important. So we made that very easy. So we use K8s, which is an open source project that basically it's a Linux meta distribution that gives you an immutable OS. And with that, we then preload content, right? With Tevel, in this case, we're using Ubuntu and K8s. And once you boot up and you install your device, all you got to do is you ship it out, and then the operator, all he has to do is power it on, right? Power it on, it connects, and then from then on, he can register the device with Palette, and you'll see an example in a second. And then once that device is registered, you can build a cluster as well. And as you can see with the cluster profile that you just saw earlier, and then the updates and day two operations are all done through Palette. So when an operator gets, for example, the QR code, so when they bootstrap and they get a QR code to scan, they will see something like this. This is a real example that we have with Tevel right now. And they will be able to add information to the cluster or to the device even. And you can see here things like device name, farm ID, and also the region where it gets deployed. For example, in Palette, in this case, we are actually using that to select where that device goes into a project, right? And that's how we do multi-tenancy in this case. But what happens when an operator is not able to actually scan a QR code, or they don't have a screen, or, God forbid, the hardware fails and you have to quickly swap it out? You don't want to have to go through all of that together, right? So essentially, we also allow zero-touch provisioning with auto-registration, and that is done by essentially, when you bootstrap the device, you can add some cloud init file with what we call the user data. And with that user data, you can specify some tags like you saw before, and also an edge token, which then authenticates against Palette and registers the device automatically. So now you don't even have to scan a QR code. All you got to do is your device failed, or you're rolling out a new device, you have to power it on, and then that device is going to be automatically registered with Palette. Then the second one, which is disconnected environments and maintaining and making sure that the functionality is still there. So as I said before, Palette has this distributed architecture. So as you can see, you might have n edge nodes, but the control plane and the management plane are basically separated. So what happens is once the cluster is running and everything is going, then the cluster is managing itself. So even if there's no connectivity back to the management platform, the node and the device and the cluster will still maintain its status, its applications, its configurations, and all of its policies as well. And this, with Tevel, happens a lot. Like Itzik said, 1 or 2 megs, sometimes no megs to update anything. So zero risk remote upgrades. So when you push an upgrade to an edge device, which is in Chile right now, if that fails, you probably don't want to ship out one of your engineers from Israel to get there, because that's probably going to take 24 hours. And 24 hours means that they're not picking, more waste, more loss as well. So with that, we're using, so as part of K8s, the open source project that I told you guys about earlier, K8s, basically, it's a container-based image, right? And what it uses as well, it actually splits your disk into two partitions. So you have an active and a passive partition. And when you push the upgrade, if your upgrade fails, it actually reverts back to the previous configuration. So the upgrade won't break the workflow. This is essentially, very quickly, I don't want to spend too much time, but very quickly, this is what our cluster profile looks. This is the live one that we have running right now. And you can see that from the OS all the way to the top, Tevel is using Flux to install the applications and maintain all of that. And as you can see, on the OS side, what Palette is doing, very importantly, is installing all of those NVIDIA dependencies, all those kernel dependencies, and also setting up all the networking for the robots with the bins as well. We're using NetBand for that. And we have, like I said, when it comes to security, some would say probably one of the most important ones, right, Itzik? Especially for Tevel, when you have all these devices out there. So because we're using K8s again, the OS itself is immutable, so your root file system is read-only. You can't install new packages or anything like that. All of that is built within the container image. You can bring your own OS because it's a Linux meta distribution. So basically, you can bring any Linux-based OS. And it's tamper-proof because of the immutability in itself. And then we have to look at TPM offline encryption. And you guys probably were at the awesome keynote with Saad and Arun earlier, and we announced our collaboration with Intel with Senna, Secure Edge Native Architecture, and this is part of that. So this is one of the components. So how do you do offline encryption? So Tevel before, they were using YubiKeys, but if you have 50, 60 bins right out in the field, then you need 50, 60 YubiKeys, plus each operator will have to have his own key, so it's impossible to manage at scale. So it's an awesome product, but just not for the right use case. So we decided to go ahead with encryption with TPM, so Trusted Platform Module, which is based in hardware. So the TPM will create a hash key. That hash key is then saved into a K-crypt challenger, which actually lives in the GCS, if you guys remember the GCS. Because the Intel TPM is in the bins, the K-crypt challenger is in the GCS. So effectively what happens is, every time the device boots, it will challenge the TPM, and it will only boot if that challenge is successful. Now, if someone comes and steals the device won't boot, and the disk is fully encrypted as well. And with that, it's like, what have we learned in these past few months now?
Yeah. At the end, Tevel wants to focus on software. We want to pick Apple right. We want to pick them good without bruising them. So we need to be focused on software and not on operation system. So this is why it's so important for us. Hardware, it's hard. You know what it is. So this is why we choose Spectra. It's the right technical. They are awesome people. It's reduced the times that we spent of building and managing clusters by ourselves and handling operation. It's frees our engineers time to be focused on innovation, more fruits. We're picking apples, nectarines, plums, peaches, a lot of fruits that we want to be focused on. So what next? With the extra time, Tevel engineer focusing to replace the GCS. We want to get rid of the GCS. It's the ground control station, and we want to reduce our infrastructure cost.
Yeah, and like I said, security, again, ever evolving, and we started with some of the concept around the Senna framework that you guys heard before from Saad and Arun. And so we're already doing part of that with persistent data encryption with TPM. But now it really is about for edge really is about securing the device from the silicon all the way to the top, right? But how do we apply that? So Tevel is already using x86 machines, so all of the computational power is coming from the Intel x86 machines. So for us, it's really all about now starting to implement in the next few weeks or so. We're looking at how we're going to start playing with Intel SGX. So think about confidential computing. So all of the different workloads, all of the different applications are enclaved into memory. And also Intel TXT, and how your application will only run if the device is actually trusted, right? So if the device gets compromised, you want to make sure, because it's all out in the field, right? So someone could, if they wanted, potentially, if it's unsupervised, go and hard connect to it and try to do something bad to it. So how do you do that, making sure that it's all safe? And the last one as well, very important around encrypted images, right? So if you think about Tevel and the fact that if you have devices out in the field and you have to update your registry, how do you do it? If you have a 1 meg link and you have 10, 20 gigs of images that you have to update, how do you do that? So in Tevel's case, what they're doing is they have operators that go out and then they manually update the registry. But what's stopping that manual operator from actually corrupting or stealing those images, which have their IP, right? So you kind of have to encrypt it not only at rest, but also in transit. So looking at end-to-end image encryption with TPM, which already exists as well on the machines. And with that, we'll show you guys a blooper. I don't know if you hear that? So this is when we were really making sure that everything was working, and we were all very excited. So this is in Tevel's lab.
Yeah, Pedro! The robot is speaking.
You can see that we were all very excited the first time when we got it working. And you can see that's Tevel's UI and also palette on the left-hand side. Yeah. So we just wanted to make it a little bit more fun. I think we have some time for questions, if there's any questions. Thank you, guys. Okay,
Any questions, raise your hand. I'll bring you the mic.
This is our robot.
This is the drone. And by the way, we're going to be at, from tomorrow on, we're going to be at S22. So if you guys want to ask us questions, check out the architecture, we can go. It wasn't too deep into it. So if you guys want to get deeper, please come by. If you want to see the drones, this is one of the mock-ups. You can play with it as well.
Yeah.
And we do have an announcement for someone very lucky. So we were running in our booth a competition. So I have, so if you guys have scanned the QR code, then you might be in it to win it. So I need to remind myself who won it. Janky's looking at me like, I've told you before.
We're giving a robot free. No, I'm joking.
Maybe the next one. In the next one, we'll give away a robot. Okay. So just remind myself of the name of that person, adding some. Ta-na-na-na. You guys write a lot in our group chat.
Never mind.
1 second. And here I was, worried about the presentation, and I think this is the. Oh, okay. So the lucky person that won this is Nicholas Ferrero or Ferrero. Oh, you're here.
Yeah.
So you got a Mindstorm. We got to keep it in the robot land.
You guys have any questions?
We got one.
Thank you. Yeah.
going to ask a question.
Oh, he's over there.
Thank you, guys. Very interesting presentation. Can the robot do the dishes? No, that's not my question. Sorry. My question is, how easy or how difficult was it to plug the TPM to the whole Kubernetes stack? Did you have a problem with the libraries that you needed to use to talk to the TPM, the PKCS11, etc.?
Yeah, very good question. So because we're using K8s, like I said, open source project. So K8s has this workflow built already. So what you have to do, so we reuse the GCS, and we use K8s, right, which is another open source project. So we didn't actually have, it was actually pretty easy with K8s to do TPM encryption. Once we figured out the architecture and what we needed to do and where basically the KMS, the key management system, was going to live, once we figured that out, then with K8s was pretty easy. Because what happens is during boot or during installation, as we call it initially, K8s will do all of that work for you in the background, and it will automatically encrypt the partition that you tell it to encrypt. So you specify, I want to encrypt whatever partition, right? In our case, it's called the persistent partition. And then K8s is doing all the work in the back end as well. So from our side, it was pretty easy to implement, yeah. So you should definitely check it out if that's something they want to look into.
Great presentation. We've got one last talk. We had two people on the program committee for this event, Oleg and Tina, who couldn't make it because they had visa issues with travel. But Tina has recorded a 5-minute wrap-up for the conference. So if you can start playing that now, we're ready to go.
Thank you, guys.
Thank you, guys.